Welcome to a new test and teardown video. This time it's a Radiometer AFM1 Modulation meter. This one covers a frequency range from about 3.5 and all the way to 320 megahertz. So you need to tune for the frequency you're kind of receiving, actually. And then it can do FM and AM demodulation or modulation measurements. I hope this one works. It's really beautiful in super good condition. It's very hard to take a photo of this surface because it's so black. I don't know if you can see this, but nothing just comes out on the pictures here. So this is from about 1963, and it's about 20 kilos. It's an all tube unit as far as I can see. And the very old models, they also got the address written here on the top. So that is also funny to note. I really like the finish on the meter here. And mechanically, it's in very good shape. There's a good feel and a good sound on this switch. It's probably a really big one. It feels like there's a massive kilo moving. And a beautiful power indicator here. I love that one. On the rear panel we see the power entry and voltage selector. And there's absolutely no way to maneuver this switch from here. Can't get my fingers in here. I can't do anything with this, so I need to take it out to be able to do that. Luckily I got those old style power connectors on stock, so I should be able to power this up. We're going to start from the bottom, because this is where we can see the most, I guess. So it consists of 3 PCBs here in the back and 1 PCBs on the side. They're all quite big, and they're mounted on like a metal frame. Yeah. Some are a little bit bent. Shielded cables and all that. Good sign of good implementation here. So they're actually full of shielded cables. So that is actually a little bit impressive, because normally you don't see that many shielded cables in old tech gear. The capacitor you see in the middle of the picture right there, what is wrong with that one? So I need to have a little look down there, that one, before we power this up. So this is the mode switch, AM, FM, yada yada, and then that is the big band switch, and everything rotates in here, by the way. You can see the switches full of coils and capacitors and good stuff. There's a really good mechanical solution for the center here. So that works fantastic. This is the fine adjust dial. I'm rotating it here. So this is geared with this thin string going all the way to a big wheel. Let me see if I can. I need to turn it a little bit. Oh yeah, it goes around that wheel as well. Cool. And that will be the input connectors, and there's actually a few resistors in here to make the two levels and the impedance. This one is modified for 50 ohms, by the way. Oh yeah, we need to open here so we can have a look. So the side panel is removed. Oh, look at the color of that PCB. It is just really, really dark. And the outside metal here, that's probably chassis. Really weird chassis wire going up here instead of just filling up the entire space of metal. Why wouldn't you do a copper pour like you would here, right? The color of this is, I mean, did this thing run 1,000,000 hours? Let's look at the back. So this is the back of the unit. I mean, I think it is fair to say the color goes darker and darker, right? I mean, this is expected because heat from the bottom goes up and heat this up and this heat up this, so it's the hottest place is of course here in the top, right? And all those tubes, they have been running really, really hot for many, many hours. The PCB here is really, really black. Some adjustments. I mean, is this 200 volts? And there's a millimeter of safe distance to the chassis? I mean, this is not exactly the kind of quality level I'm used to when it comes to radiometer, and especially not up here. I don't know if we can we lift this? I mean, yes, there is a distance, but it's 300 volts distance, and it is just barely touching chassis. Oh no. You can even see, the trace here? Dust kind of suck into high voltage traces more than lower voltage traces. So this is actually quite evident on this track. And there's another one here with a relative higher voltage compared to the other tracks. Yeah, this is how it is. This is how physics works. And this is the mains transformer. And there's a voltage regulator tube in here. And a bridge rectifier with tiny little diodes. They look very, very... maybe this is just dust. Inductor for high voltage filtration. And then we go directly into everything. Oh, there's a nice little bulb. Ui, ui, ui. How many hours did this unit run? Oh, look at that. Somebody modified the brightness, and that is a typical radiometer problem. The bulbs for meters and stuff, they just run normally from brand new. They were designed so you needed to wear sunglasses to use this instrument, and somebody here was probably tired of that. Of course, this is a good fix. Yep. Tons of switches. Yeah, I think it is safe to power this up now. So this is what I would do. We got a lot of bulbs. Those bulbs, they show the different frequency ranges, so they light up the different scales in this meter. So they light up here, or here. So this is what we are going to see. Hopefully those bulbs works. I don't think I got any spare, but I'm a little bit worried about the color here. This color is a typical something blew up in here kind of color. This is not so normal. This dust color here, this is kind of the normal level, but this is not so good. So, well, let's just try and power this up and see what happens. So I just powered it up. It actually just went on when I applied mains and the lamp was on. So, oops, I forgot to start the camera. This is 83, 84, 85 watts, more or less. And I do see what I expected here, so that is good. My God, that wasn't as bright. This actually hurts my eyes. Are you kidding me? Oh, there's something here. Level, tune. Oh, look at that. The different, all the bulbs works. 1, 2, 3, 4, 5 bulbs. Yes, all of them work. Don't you just like this kind of indicator? Oh, this is so nice. I better go find a signal and see if it actually works. But this is a good sign. Oi, oi, oi. So let's try and measure something. So here's what I did. I am now in 14 to 28 megahertz range. My signal generator is set for 20 megahertz. And here on the screen it's more like 21. So first I go for level. And then I adjust the tuning and the level for the level here, right? So see? So this is the level. Then we go to IF check. And then we need to hit that one. Then we go back to level. Yes, level is good. IF, oh, we need to massage the switch a little bit. Then it's good. Then let's go to FM. Again. Okay. I probably need to clean them a little bit. So that means this meter is now, I think this is the FM deviation in kilohertz, right? So this means 3 kilohertz full range. So this is 1.23 kilohertz of deviation. So what I did is I got only 1 kilohertz of deviation. So down here in this very low deviations, it's not super accurate. So let's go to 10. And let's crank up the deviation. That is 5. And then it says 6. So it shows a little bit too much. I think this is something we can calibrate, of course. So this is 30. Okay, let's go to 10. And again, it shows a little bit too much. Let's go all the way to 20. And then it's more like 25. Okay, so I think there's a general thing. Let's just crank it all the way. 300 kilohertz, right? Oh well, Yeah, of course I can do that if you want 300. So this is 100, 200. Okay, so this is 200. So there's definitely something with FM. So how about we try AM? So now we're playing with AM, and I think it works the same way. Of course, I need to massage this switch a lot more. So IF check is in the middle, level is there. Let's go to AM. So that will be 30% full. So this is 10%. 10%. Ha ha. Okay, let's try and say 0%. Or 1% is okay. So this is 10, and this is whoa. That was the 20. That was 30. Okay, let's keep it at 30, and then let's 100% AM modulation. 40, 50, 60 is a little bit low there. 70, 80, 90. Okay, but in general, this meter is working. All we need to do is figure out how to calibrate a little bit and clean the switches a little bit. So that is definitely a very, very good day. I will now go and play with the different frequency ranges and see if that works. So I set the generator for 220 megahertz. And that is 220 plus a tiny little bit, and this is where we are. So the error is very, very little on the high band here. So the next band, I just take this center point, so that is 120. Let's see if we can find it. Yep. Ooh. This is definitely a two-hand job. So 120 is a little bit off here, but it's probably something we can adjust that way. And here we go for 80 megahertz. And again, it is really, really close. So this is the lowest band. I actually input 5 megahertz now, and I found the peak, and I mean, here's 5, and it's way off in the lowest. So I think I will go and look at the schematic and see if it's possible to move the scales somehow. I removed the lids here for the band selectors, so now we can see much more clearly what is going on in here. But the problem is the selected band you can't really trim as far as I can see. It's both on the inductor and the capacitor. It seems like you can adjust both of them, so that is going to be interesting. So you need to go there and figure out what's going on, then up here, then dial it in and go back and see what's going on. Yeah, that's just the way it is. So I'll see if I can figure this out. Can't get any worse than it is actually, right? After a little bit of try and error, I'm actually able to figure out how this works. So that is 5 megahertz, and my signal generator is also 5 megahertz. And I believe I don't know if I can show you this at the same time. See the meter to the left? Yep. I mean, more or less. Center of its bandwidth is about here now. So now I'm quite happy. I think I figured out how to do this, and the method is actually a little bit stupid if you ask me, but so I dial this way, then I find poke and then go back and see, is it more, is it left? And then do this a million times and then you actually figure it out sooner or later. I don't know, this can't be the right method, but that is my way to do it. See, this is 20 megahertz, the next range, and I'm doing exactly the same. I'm just so much faster to do it now. See, a half to one side and then it goes down, and a half to the other side almost. See, so I think I'm more or less in the middle here for 20, and that was the two ranges that was really off. So I think I'm done with the frequency alignment, and now I will play a little bit with the demodulation alignments. Why not? It's a lot of fun. See if I can make this unit go accurate again. So now I can assemble this little thing, the box here. So I'm done playing with this unit now. After all my adjustments and stuff, I'm quite happy about it. I just changed the bulb in the meter and adjusted the resistor, so now it is quite all right. And this is the oscillator tube. It is of course located down here close to the coils and capacitors and all that stuff. Look at all the wheels and wires and stuff. That is something, isn't it? Maybe I would have put some sort of a shielding over the capacitor, at least for dust and stuff, so it's nice and clean. So thank you for watching, and please come again tomorrow for more.